All right? So what we're going to talk about in this section 4.4 is sometimes getting the total takes some work. Now, sometimes it doesn't take any work to know the total. If you're dealing with a deck of cards, how many are there? 52. That's a fact you can just memorize and know. All right, when you are rolling a die, like a regular die, how many things are on the die? You know, right. Now, it would get stickier though if I said something like this. Let's even suppose we're in the middle of a pandemic and I've only got 5 little kindergartners. Everybody else is home. I want to know how many ways you can line 5 kids up to go to lunch. Well, it's much different than you think it would be. So what we're going to talk about today is this. Your homework, the probability part is not going to be that challenging. What's going to be challenging about it is you're not going to know the total to put on the bottom. Okay? So we're going to talk about ways to calculate a total. Now, we're going to write down 3 things, and then we're going to fill them in kind of. I want them kind of written already in your notes, though, before we start talking about them. One's going to be something called the counting principle. The second thing is going to be something called permutations. And the third thing is going to be something called combinations. Okay. And I'm going to tell you some facts about each, and then I'm going to distinguish between them, and we're going to go work some problems. Okay. But I found out from years of experience, it's better if you just go ahead and have it in your notes first. Here's one thing that's important on the counting principle that you need to remember. Order matters. Order matters when you're doing the counting principle. Something about permutations you need to understand is that order matters. With combinations, order does not matter. So there's your first distinction. When you're reading these problems in a minute, the first thing I ask myself is, does order matter? If the answer is no, I know what to do. If order does not matter, what's my only option? Combinations. You don't know what it is yet, but you know that's what you're going to be. If order does matter, this one's off the table. You've narrowed it down to 2 choices. Well, now, how do you decide between these choices? Well, on permutations, there can be no repetition or special conditions. No repetition or special conditions if it's permutation with what you've got in your book, with the formulas that y'all are going to be looking at. With the counting principle, you can use it with or without repetition. And you can use it with or without special conditions. So what I need you to already notice is the counting principle is more versatile than permutations. It'll do everything that permutations is doing with the kind of problems you're going to be working out of your book and more. So if which one you're kind of fuzzy, should I do this one or this one, which one should you do? Now, we'll get back to lining the kids up for lunch in just a second. All right, so you got that on your notes. I'm gonna switch forward, so you need your notes next to you. Now, when you graduate MC and you go get a job, all right, for most people, they have to go shopping. Because you can't wear your sweats to the office. Okay? But you're poor because you don't have a job yet. So you're kind of in a catch-22. So one of the things they will teach you in a professional protocol class is this. When you get your first job, what you want to do is you want to buy a few pieces of high-quality clothing in some color scheme so that everything matches. So that means every pair of pants has to match every top. Is everybody with me? We're not gonna wear some fuchsia, pants with an orange top, you like have a seizure. Okay. So a lot of times people will pick they're gonna do like a black, gray, white, or maybe a black, gray, red if they like a splash of color, Maybe somebody else is gonna do more of a brown, beige, yellow, but every pair of pants matches every shirt. So what if I tell you this? You go shopping and you buy 2 pair of pants and you buy 3 shirts, 3 tops, whatever you want to call it. And I say, how many outfits can you make? How many outfits can you make? Now, in your book, the counting principle is on page 169. Look what it says. It says this. For a sequence of events in which the first event can occur in sub 1 ways, and the second event can occur in sub 2 ways, and the third event can occur in sub 3 ways, and so on, the total number of outcomes is, what are they doing with those numbers? What's that dot mean? Well, the 3 dots to the end mean continue, but what's the dot between like N1 and N2 and N2 and N3 mean you're gonna do? You're gonna multiply. So what am I talking? Am I talking about this? When I go to pick out my outfit that morning, all right, we're not gonna go half naked. So we're going to pick out a pair of pants and we're going to pick out a top, a shirt. Now, according to the counting principle, I do these things separately. So when I go to my closet, how many choices do I have for my pants? 2. And I go to pick a top, a shirt, how many choices do I have now? 3. So I can do pants 2 ways. I can pick my shirts 3 ways. So what's the counting principle say I do with these 2 numbers? I multiply. And get how many outfits? 6 outfits. So I bought 5 things, but I can actually go more than a week and not wear the same thing twice to work. You like big whoop. I get you. But watch the power of it. You work for a month and save up a little money and you go shopping. Now this time though, you buy 2 jackets. Now I want to know how many outfits can you make. Now, I'm going to define my outfits now as a pair of pants, a shirt, and a jacket. So when I go into my closet that morning, how many choices do I have for pants? 2. How many choices do I have for a top? 3. What about a jacket? 2. What's the counting principle say I do with those 3 numbers? I multiply. Now how many different outfits do I have? 12. I go 2.5 weeks. But I didn't buy like 6 or 8 more things. I just bought how many things? 2. And the truth is, if I leave the jackets off some days, I even have 6 more outfits. Which means now I can almost go on month and not wear the same thing to the office. That's why they tell you to do that. Okay, so the fuchsia jumpsuit's just lovely, but you know, wait till later when you have more money. Because when you wear that, I've seen that, I'm gonna remember that, you wore it like Wednesday and now it's like Monday, you wore that like 3 days ago. Okay, so that's what the county principal does. So think about, let's go back to our question. How many ways can you line up 5 kids? All right, so we gotta go to lunch. And I got 5 kids. Now, I will do this for you on a test because everybody doesn't work with children. You can ask me on a test, does order matter? And I will either shake my head this way or I will shake my head that way. Now, anybody that's ever worked with 5-year-olds, does the order they go to lunch matter? Oh, yes. The fact that you're going to the same place a half a second later doesn't matter. You know what I'm saying? Like, it's a big freaking deal where you are in that line. So if you don't know that on a test, I'll sit there and fret. Just come up and ask me, does the order matter? Going like that. Now, do you understand? It's like there are 5 positions at the door. So if I'm the teacher, how many choices do I have for this first position?
5.
I've got 5. Maybe Anna's being so good, so Anna goes to the door and she's first. Okay? Now I go back and I look at it again and I say, okay, now how many choices do I have?
4.
I got 4. Now Morgan, you can go. You're being so sweet. Okay? When I go back, how many choices do I have?
3.
3. Then how many choices do I have?
2.
2. How many choices do I have?
1.
1, I like to put that child in the closet, but you go to prison. You know what I'm saying? Like, I only got 1 choice. That kid will have to go to lunch. What's the county principal say I do with these numbers? So answer me that question. You've only got 5 kids. 120 different ways to line those children up. I'm probably gonna have 21 kids. You know what I'm saying? There's a lot of decisions to make. That's why you're exhausted at the end of the day. All right, there's 120 different ways to line those children up. Now, notice though, every time I take it blank by blank by blank, as long as you take it blank by blank by blank, it's simple. All right, so look at one that looks complicated, but it's not. Let's say that you're gonna make a secret code. Okay. All right, suppose a secret code consists of 4 single-digit numbers followed by 3 letters of the alphabet.
This one's pretty good.
All right, suppose there's some conditions. Suppose the first 2 numbers have to be even. And suppose the first letter, for some reason, cannot be Z. And no repetitions allowed in anything. And I want to know how many codes are possible. Okay. How many codes are possible? Now, does order matter when you're making a code? What do you think?
Yeah.
A secret code? Yeah, but if you don't know the test, what can you do? You come ask. I'm telling you, order matters. Are there any special conditions?
Yes.
Yeah, so I can't use whatever this thing permutations is in a minute. You see what I'm saying? Order matters, so combinations is gone. I've got special conditions, so permutations is gone. So that leaves me with the what? Counting principle. Now, what I'm doing, I tend to write notes to myself. Okay, so you understand that you've got 4 single digits. So these are numbers. Then it's followed by what? 3 letters. What about the first 2 numbers? They have to be even. So this one's got to be even, and this one's got to be even. What about the first letter? It can't be Z, not Z. I mean, you don't have to do that. That's just me. And I can't repeat anything. Now, when it says single digit numbers, what numbers am I talking about? What are all the single digit numbers in the number system we use? 0 to what? 9, okay. When I'm talking about letters of the alphabet, we're doing English alphabet, so what letters is that, like A to Z? All right, so when you go pick this first number, it's got to be even. How many choices do you have? Think about it for a second.
5.
How many?
5.
Why 5? Because you can pick a what? 0, 2, 4, 6, or 8. Now, don't say, well, 5's not even. I'm not saying 5 is even. I'm saying there are 5 different even numbers from which to pick. Now, when I go pick the second number from my secret code, how many choices do I have now?
4.
Why 4?
Because you already used 1.
Because you used 1 and we said no what? No repetition. Oh. How many choices will I have here?
8.
Why 8?
Because it can be big.
Because it's got to be a number, which means there are how many choices? 10, right? 0 to 9. But what?
Just pick 2.
I've used 2 numbers, so they're gone. So what's that leave me? It leaves me 8 possibilities. How many choices will I have for this number? 7. Because again, there are 10 single digit numbers, but now I've used up how many? I've used up what?
3.
3. Okay. I got to pick my first letter. How many choices do I have for that letter?
25.
Why 25?
Because you can't do Z.
Because there are 26 letters, but Z is not a possibility. Now, don't say anything for a second. I want you to think about how many choices I'll have here. Just a second. Think about it for a second. Is it 24?
No.
What is it?
25.
Very good. Why is it 25?
The Z's back on
Because
the
Z is a
table.
possibility. So I used 1 up, and it's gone, but now Z's thrown back in the mix. What's that gonna be?
24.
Because there are 20, there's nothing special about it. There are 26 letters, and I've used up how many?
2.
2. See, there was nothing special about this one. There were 26 possibilities, and I've used up 1. So what's the counting principle say I do with all these? All right, so go find me that answer. What are my numbers? 1 what?
6.
6.
8.
How many zeros? 16,800,000. You okay? All right, so suppose we do this? Suppose let's go play the lottery. Let's do that. Suppose we're gonna play 5-number lotto. Now, different lotto games have different rules. You can play 3-number lotto, you can do matching this one, matching that one. But standard, think about it. 5-number lotto. Suppose we buy one ticket and I ask you, what's the probability that you win? What's the probability that you win? Yeah, like I said, different states, different places do it differently. We'll work this one again in a second. Okay, probably. But suppose you're playing the 5-number lotto where order matters. Remember what I said? If you want to get any partial credit, you have to have the probability that you, what am I trying to do here? I'm trying to what? Win. So I've got to know the total on the bottom. Now, what do I mean by the total? I mean, I'm walking up to the 7-Eleven and I'm picking my ticket. Now, I need you to number that most of the time on like a 5-number lotto, you understand they're not single digits. Do you know what they are? They're double digits. So that means this number is 0 to 99. This number is what? And they ask you, what numbers would you like? Well, how many choices do you have for this first one?
99.
100. 24, because I was born on the 24th. All right, well, how many choices do you have for this one? 100. Oh, my daughter's born on March 4th, so I'm gonna put 3, 4. Having all these blanks. What's the kind of Christmas say I do? Go do that one. How many zeros do I need? 10. What number is that?
10 billion.
10 billion. How many tickets do you buy? You feel like that. And you say, well, I'm gonna buy 5 tickets. Ooh. Now your chance is not 1 out of 10 billion, it's what? 5 out of 10 billion. Now I need you to understand something. This is not like buying a ticket for the quilt at the church. First of all, I need you to understand this. If these tickets are, say, $5 a piece, if they sell 1 million tickets in the state of Mississippi, then how many do they not sell? 9,995,000,000 what? Million didn't get sold. You think anybody's gonna win? No. So even if that's $1 million pot, if they sold 1 million tickets at $5 each, that's 5 million. Right with me? Nobody won that million. Now the pot jumps up to like 1.5 million. So now 2 million people go buy tickets. So how many did not sell? 9 what? Billion. 900 what? 98 what? Million, everybody with me? Who gonna win? Nobody. So now they got $10 million more. So they could throw another million in the pot. All they're doing is cutting their profits slightly. Everybody with me? And the bigger the pot, what? The more tickets they sell. If you want a thrilling 30 seconds, that's great. But I need you to understand. First of all, here's what research shows. People that win those big pots of money in 5 years are poorer than they were before they won. The vast majority of the time. Why? Yeah, first of all, financial geniuses are not going to buy these tickets. What happens when you win? Do you know the first thing that has to happen when you win? They take taxes out. How much? It is a bit of my head. So you go buy your mama a house. You go buy a brand new ride for yourself. All your free. Everybody with me? Well, the next year you still got to pay property tax on that house. You see what I'm saying? I need you to be real clear about this. I'm not saying don't do it. I'm just saying if you were to win, the first thing you better do is get a lawyer, and the second thing you better do is get a financial planner. And I need you to understand, they will sell the same ticket twice. You do know that, right? Like when you buy the ticket, ain't nobody else can buy that number. So what if two people win? What happens? The pot's what? Split. So I'm just saying, now sometimes order doesn't matter. Well, that's going to be combination. I'll have that in a minute. Is everybody with me? So my things come slightly up, but I'm saying you're not going to be, this is not a good financial retirement plan. Now, I got a thing the other day in the mail to buy the ticket for the St. Jude house. Now, I've done that before. But that's different, but I've still got to be, I know what I'm doing, and what I mean by that is St. Jude, the Children's Hospital, raises money. They have houses, like the house might be valued at like $300,000. The tickets are $100 a piece. Okay? But first of all, they cut them off and sell only like 6,000 tickets or something. So now my chance of winning still minute. It's like 1 out of 6,000. Is everybody with me? But I buy it because I support St. Jude. So it's like a $100 donation. Is everybody with me? But I need you to understand, what people don't understand is this. If you win the house, what do you have to do before they hand you the key? What's the first thing that happened when you won that lottery? Guess what you got to pay now? You got to pay the taxes on that house. Because my income just went up $300,000. I don't have 25% of that in my checking account. I don't know about you. But before they hand me that key, I got to come up with that 25% or I don't get the key. When you watch The Price is Right, if they're just screaming about what they won, I was like, What you got to do before they hand you that car when you leave? You got to hand them the what? The taxes. If you can have the taxes, what? You don't get it. So what most people have to do that when they say Jude house is, I have to go borrow the money to pay the tax. So if that house is $400,000, I've got to come up like $100,000 to get the house. I don't have $100,000. So I got to go to the bank and get them to loan me $100,000. Now, will they loan me $100,000? Yeah, probably, because I've got his collateral, $400,000 what? House. So I've got a couple of choices. Now I owe $100,000 I didn't know yesterday. Everybody with me? So I'm going to turn around and sell the house to pay off the what? The loan. But if the house is $400,000, if I even sold it for $300,000 and paid off $100,000, I'm cleared $200,000. Everybody with me? So it's still, but you have to know that before you run around with the keys screaming, I'm gonna live here. So you gotta know what you're doing. When you're playing slots, or when you're doing lotto, or when you're, the little balls that pop up, the little pink, same kind of thing. You need to know most of the time when you're gambling, you're paying for an experience. All right, so what I mean by that is when I go to the movies, if COVID ever leaves again, I cannot wait, and I go in a movie theater, it costs like $900 watching about popcorn. Is everybody with me? So when I leave, what do I have to show for it? Nothing, except the memories. Everybody with me? Hopefully, I hope it was the good ones. Everybody with me? It's the same kind of thing when you're gambling. Whether you're betting on the Kentucky Derby, like I talked about last time, whether I'm playing lotto, whether I'm doing everything. You just got to know what you're doing, because most of the time, you're not gonna win, you're paying for an experience. So I had a friend who used to laugh at me all the time, because she would just be like, you can go all you want to, knock yourself out. So they went to New Orleans, her husband had a convention, so she's down there, and she comes home and she is just doing the happy dance. And she's going, I told you. I said, you told me what? She goes, I won $1,000. I said, well, that is fair. I should not have been so snarky. So year and a half later, she gets a bill from the IRS. Because she didn't pay Louisiana state tax. But she had an income of $1,000 from Louisiana. Once that penalty came in, she was in no. I didn't go up, but just a little bit. So if you win at the casino, you better ask when you pick up your money, have you taken the tax out or not? If it's in a different state, you probably have to file an income tax in that state. Okay, so now that I want to go gamble. All right, now, let's talk about permutations. Now, let me show you this symbol and make sure we're clear. So your calculators are out. All right, that is not an excited 6. Okay, it might be, but that's not the point. All right. This exclamation point is called a factorial symbol in math. Here's what that literally means. 6 times 5 times 4 times 3 times 2 times 1. You start with that number and you go down 1 until you get to 1 and you multiply it. Okay? The reason I'm telling you that is because the formula for permutations has that exclamation point in it. Okay? Jared?
Why would you stop at 1 these times but continue at 0 with the other ones?
Because I'm not, this is just a notation. This is not how many things you can do. 6 factorials is a weird way of writing 6 times 5 times 4 times 3 times 2 times. Okay, good question. Now, here's your formula for permutations in your book. There's a P, there's an N, and there's an R. It's N factorial over N minus R in a parenthesis factorial. N is your total. Did I tell you in every formula what was N going to be the whole semester? Your what? Your total. R is how many you're picking. How many you pick? Okay. So suppose I tell you this. Suppose there are, let's just use some round numbers. Suppose, let's make them a little bit smaller. Suppose there are 75 people in your tribe or your club. Okay, and suppose you have to have a homecoming committee. All right, suppose you're gonna have, for simple sake, let's say 5 committee members. Or let's even do it this way. Let's say we're gonna have officers. Let's have 5 officers. Okay. And the first person is going to be the president, and the second person is going to be the vice president, and the third person is going to be the treasurer. So the order matters. Everybody with me? And I say, how many slates are possible? many slates of officers are possible? So then it matters if like Amy's listed first or fifth, because first is for president, fifth is for like swerve chair or something, okay? Now, so I'm telling you order matters. So if order matters, what can you not use? This thing called what? Combinations is out. Are there any special conditions here? No. Am I gonna repeat the same person for two different offices? Can you be president and this at the same time? What? No. So I can either use permutations or I can use the what? County principal. I'm gonna do it both ways. All right, if I'm gonna use permutations, what's my N here? What's my total? How many are there to pick from? 75. How many am I picking? 5. So do you understand that my N is 75 and my R is what? 5. So I have 75 factorial over, I've got what? 75 minus 5 what? Factorial. Now, that's 75 factorial over, what's 75 minus 5? 70 factorial. Now, does anybody want to do 75 times 74 times 73 times, you with me? So see if this makes sense to you. Do you understand 75 factorial means 75 times 74 times 73 times 72 times 71 times, why am I going to stop with 70 factorial?
Is that how many?
Because what's on the bottom?
70 factorial.
So what can I do with this 70 factorial and this 70 factorial? Will they divide out? That's quicker than me doing 79, 60, me doing 70, 69, 68. Everybody with me and slashing out like 70 numbers up here and what? 70 numbers down there. So go find me this answer. How many different committees can you make? I mean, excuse me, not committees. How many different slates of officers can you make? That's a bunch of different officers. It's like 2 billion. Now, did I have to use permutations? No, I could have used the county principal. Is everybody with me? Aren't there 5 positions? When I go pick the president, how many choices are there? 75. When I go pick vice president, how many choices are there? 74. When I go pick the secretary, how many choices would there be? What? 73. What? 72 and what? So what do I do with those according to the county principal? I multiply them. So I'm telling you, this one's more versatile than permutations. I'm going to show you there is an advantage to permutations and stuff. But county principal, if you're in doubt, if order matters, use the what? County principal. Which one do you use when order does not matter? Something called what? Combinations. Here's your formula for combinations. All right. It's n factorial on the top, n minus r in a parenthesis factorial, and an extra r factorial. So the only difference is in this formula and this formula is I've got an extra r factorial at the bottom. So let's go back to the tribes. There's 75 members. And we're going to pick 5 members for a committee. Now, if you're picking a committee, does the order matter? No, if I pick Sarah first or fifth, she's still on the same what? Committee. So it doesn't matter. So if order doesn't matter, I have to use this thing called what? Combinations. All right, what's my N in this problem? What's my total still?
75.
75. And how many am I picking? I'm picking
5.
5. So I've got 75 factorial. I've got 75 minus 5 in a parenthesis factorial and another what? 5 factorial. So do we understand that I've got a 75 factorial over a 70 factorial times a 5 factorial? Everybody with me? Now, 75 factorial means 75 times 74 times 73 times 72 times 71 times, why am I gonna stop with 70 factorial?
That's the problem.
Because I've got one on the bottom that I can divide out with, right? And what does 5 factorial mean?
5 times 4 times 3 times 2 times 1.
That's right. So 70 factorials go out. So I've already got this number over there, and I'm gonna divide it by what, 120? So if you wanna do it in your calculator all at once, just make sure you put the top thing in the numerator, I mean the parentheses around the numerator, and parentheses around the denominator. So if I multiply this top out, I get the same number I got over here. But I'm gonna divide it by what?
120.
120. So now I only got a little over 1 million. Is everybody with me? Now, let me show you a couple things. On your calculators, there's a key called math. All right. It's on this first column, it's the third button down. All right, does everybody see the math one? All right, I want you to hit your math key. Now, across the top, mine says math, MUM, CPX, and then the last heading says PRB. Is that what yours says? What do you think PRB stands for? Probability. So let's arrow over to that. Now, first of all, what's number 4 say?
Exclamation point.
There's that factorial. So you get, now here's the problem. If you, let me show you something. Go back, like hit clear. What if I want to know what 75 factorial is? Do 75 on your machines. So type in 75, now hit your math key. Go over to probability and then go down to number 4. And hit enter and look what it does. The whole thing just starts smoking. Mine says error. Why does it say error? It's too big, you can't do it. I mean, if my calculator would do 75 factorial, I can get that answer and then get this answer and divide them, but it's too what? It's too big. So sometimes you have to get smarter than the calculators. Everybody with me? Now, but go back again to your math key, go over to probability, and look at number 2 and number 3. What? These formulas are built into your machine. So let's go back and work this one first. All right, so clear your machines out because you have to do it in the right order. You have to type in 75 first. You have to type your N in. Then go to math, and then go over to probability. Do you want NPR and CR? What do I want on this one?
NPR.
So then go down to number 2 and enter it. Is your cursor blinking? It's wanting you to type in what? Your 5, your R. Now hit enter. Voila.
Love it.
So let's all tell Jesus, thank you. Okay, then go do this one for me with your calculator. Go do the NCR one with your calculator. So if you don't have this calculator, you gotta do it by hand. Already worth your money, isn't it?
Mhm.
And see if you get it. Okay? So if you don't have it, then you gotta do it by hand, and that formula's not on your formula sheet. So you gotta learn it. Now let's go back and double check. So when you're doing your homework for tonight, most of the time, you're gonna be missing the bottom number. So you're gonna have to do one of these three things to get your total. So the first thing you better ask yourself is, does order matter? What if the answer is no, order does not matter? What do you have to use?
Combination.
You have to use combinations. When you go to Wendy's and order a combo, does it matter whether the burger or the fries in first? What? It does not. It is a combination. The order does not matter, all right? If order does not matter and the answer is no, then you use combinations. Now, if the answer is yes, you got another question to ask. And that is, are there special conditions or repetition? And again, you're either gonna get a yes or you're gonna get a what? A no. Now, if the answer is no, there are not any special conditions repetition, you can use the counting principle or you can use permutations. If the answer is yes, you have to use the what? The counting principle. So with what the problems in your book, this isn't true always, but the problems in your book, if order matters, and you're in doubt, what should you use? Counting principle. The only advantage of permutations is it's built into your machine. Where's your homework gonna be? See if you need it.